Hello dear students. In this video we will be discussing about how to write a Python program in the case of the numerical integration technique Simpsons 1 by 3rd rule. I will be giving two different programs. Both of them are somewhat similar. One contains two for loops and the other one contains only one for loop. That's the major difference between the two programs. Let's get on to the program. So, in the case of numerical integration and Simpsons rule, you have a function f of x. You have to integrate that function on the interval a and b. So, you have to define the endpoints a and b. So, in the input section, the first thing I'm going to define is a, which is input enter the first point. The second endpoint is input enter the second point. Both are strings. And now in numerical methods, you will be subdividing the entire interval AB into some number of panels. You have to specify the number of panels to get the approximate answer. As the number of panel increases, you will get more and more correct approximate answers. So you have to define the number of panels, or you have to enter the number of panels. These three things are the main input parameters in the case of Simpsons rule. Now the thing is, you have to convert these strings into numericals. So a and b are real numbers, so it should be converted as float values. A is equal to float a and b is equal to float b. In all the cases, n, the number of panel, should always be an integer. So n should be equal to integer n. Now we define a new variable h, which will be the length of each panels. If n is the number of panels and AB is the interval, then the length of each panel should be b minus a divided by n, which is defined as h. Now, in this problem, I will be trying to find the integral of sin x. So, you have to import the package math for the Python to read the sin function. So I'll be importing the package math. So I define the function f of x, and f of x should be sin x. So it should be written in the form math.sin x, as we have imported the package math. Now we are moving on to our main part of the program. So we define a new function which is Simpson AB, which depends upon the variable a and b, and we define two sums. In the case of Simpson's rule, there are two types of integers or two types of points. First one is odd indexed points, that is, which is obtained by multiplying h odd times and adding on to a. So in that cases, the value of the function is multiplied by 4 in the numerical part, and there are even indexed points, which is obtained by multiplying h by an even integer and adding on to a. In that cases, the value of the function is multiplied by 2. So you have to define 2 points in the case of even indexes and in the case of odd indices, or in the case of even integers and in the case of odd integers. So in the initial stage, I define the sum as 0. S is equal to 0 and t is equal to 0. One is for odd indexed values and the other one is for even indexed values. So I define a loop for I in the range 1 to n. That means that I should be equal to 1 to etc. up to n minus 1. Here x naught, the first point, should be a, and the last point xn should be b. So you have to eliminate n. That's why range 1n. Range 1n contains 1, 2, 3, etc. up to n minus 1, not n. And now we have to separate I into two cases. First one is even and the second one is odd. So I divide I by 2. So that's why I define another loop. If I percentage 2, that is I by 2, gives a remainder 1, then which means that I is an odd number. Then you define the point x as a plus I star h. Then define the sum as s is equal to s plus f of x. That is, so for the first odd number, you define the value x as a plus 1 into h and find the value of f of x. And the next odd number is 3, and we define the value of x as a plus 3h, and s should be equal to f of x1 plus f of x3 and so on. So this concludes the section of odd integers. Now we have to define the case of even integers. If I is not an odd integer, then it should be an even integer. So that's why this part else. So if I gives a remainder 1 when divided by 2, then that part means that I is an odd integer. Else it means that it's an even integer. So in that case, x is defined as in the previous case, x is equal to a plus I star h, and the new sum t should be equal to a t plus f of x, which implies that which is the sum of the value of the function at even indexed points. Now the integral should be the value of the function at a plus the value of the function at b into 4 times the value of the function at odd indexed points and 2 times the value of the function at the even indexed points into h by 3. So that's a new thing which we have defined as integral. So integral should be equal to f of a plus f of b plus 4 star s plus 2 star s t star h by 3. And we want the output to be printed as the integral is of the form, this form after the percentage up to 9 decimal digits. That's why this 0.9 specifies. Okay, and what should be printed after the percentage should be noted after this percentage sign. So in this case, the integral is the numerical value of this answer. So we call the function Simpson AB, and now let us run our program. So we enter our first point as 0, next point as 3.14. You can write it as pi as well, but we haven't specified pi in the case of in the program, so we have to be numerical. I write the number of panels as 16. The answer is 2 points this value. This is almost similar to the values which we have obtained for the same problem in the case of trapezoidal tool. So this is one program which contains only one loop, and you can write another program as well which contains 4 to 4 loop. As in the previous cases, you have defined a, the first endpoint, you have defined b, the second endpoints, you have defined n, the number of panels, and you convert a and b and n into numericals by a is equal to float a, b is equal to float b, n is equal to integer n, and the length of the interval is defined as h is equal to b minus a divided by n. As in the previous problem, we find the value of integral 0 to pi sin x. So sin x is a math function. You have to import the package math. So definition of the function f of x should be returned as math.sin x. In this case also, you have two sums. One is for even and another one is for odd. So corresponding to that, the initial stage of sum is defined as s is equal to 0 and t is equal to 0. And we define two loops for even and odd. For I in the range 1, n, 2, which means that so it contains all the numbers 1 up to 1 to n, starts from 1, and the numbers are separated by a length of 2. This is what this 2 means. So the first one is 1, next one should be 3, next one should be 5, etc. up to n. Okay, it does not contain n. So if n minus 1 is odd, so it should come up to n minus 1. So it contains all the odd numbers. Then x is defined as, in the earlier case, x is equal to a plus I star h, s is equal to s plus f of x, which means that the sum of all values of the function at odd indexed points, and so which completes the value of the values of odd indexed points. Now let us move on to the even indexed points. You can define as in the same cases. You considered all the odd points here. You have to consider the even points. So for I in the range 2 to n minus 1, which is separated by 2, which means that the first point is 2. The next point is separated from 2 by a length of 2. So the next point should be 4. The next point should be 6, 8, 10, etc. and so on. So x should be equal to a plus I star h, which is defined as earlier. So t should be equal to t plus f of x. That is the value of the function at even indexed points. So we have defined the value, sum of the values at odd indexed points, and we have computed the sum of the values at even indexed points. Now we should obtain the integral. So the integral should be defined as in the previous program, which is similar to this part: f of a plus f of b plus 4 star s plus 2 star t into h by 3. Okay, now you should get the output as print the integral is, which is correct to 9 decimal points, and this part should be, answer should be the integral. So that's what this percentage after, which means, okay, so we'll call the function Simpson AB. Now let us run the program. It should give the same answer as in the previous cases. So I will write the same points. The first point is 0, the second point is 3.1415, the next number of panels is 16, and the answer is same. You can see that both these answers are same, and you can also verify that this is a problem which we have done uh, in the textbook using trapezoidal rule. You can check, the answer is almost same. Okay, so this is two programs uh, which can be wrote in the case of Simpson's numerical method. Thank you.